Hi everyone. So this is Gloria Ojukwu. I'm going to be your coach for this particular challenge. And welcome, actually, welcome. I'm excited to have you, in this challenge. We're going to be going through this problem together, and you're going to be learning how to tackle things from the technical aspect. So, my name is Gloria Ojukwu. In case you don't know me, you can check me out on LinkedIn. And so let's start. Let's go through the challenge problem before we go ahead. So I'm gonna be reading from the challenge. So you're a product manager at Learnify, an online learning platform where learners enroll in courses, watch video lessons, complete lessons to earn skill and certificate. Users are complaining that their progress is not accurately saved. They can't tell how much of a course they've completed. Certificates appear locked even after completion. You will learn how to one technical product management for edtech industry, how to define and design API construct for the edtech platform, how to do system design for the edtech platform, entity relationship diagram for edtech, algorithm that solves learners needs. So let's go ahead. So for this particular stage, so this is stage one, we are going to be looking at the problem scope or the problem framing, however I want to put it, and also the system design fundamentals. So before we go ahead to start designing the system, let's look at the fundamentals of the theory part of it. So let's go ahead. So for the problem framing or problem scope, I think we should call this problem framing, right? So let's rephrase it. So when you're going through it, just take it as problem framing, right? That sounds better in this context. So for this platform, Learnly, this is supposed to be Learnify. So I think this was an error. So this is an edtech product. And so for context, you need to pay attention to the industry because the industry also is going to give you some special or particular insights on the way to tackle it, right? And also users complain. So these are the users complain progress not being saved correctly, can't see course completion, and certificate appear locked. So this is what the users are saying. So the goal of this stage is for you to learn to understand how the problem, to learn how to frame and understand the problem, and then the fundamentals of system design. So what is problem framing? Right. So for you to be able to frame your problem very much well, you need to first of all identify who is affected, right? You need to identify who is having the issue, and then describe what is broken, explain why it matters, and define success. So this is an example in this context. So for example, user complaint. Now notice that the user complaint might not be the same, like in nutshell or holistically, right? You see that they might mean the same thing just looking at it, but from when you look at it like in like very much, you notice that the way a user will frame the problem will be different from when you're trying to solve it technically. So for example, progress resets unexpectedly. So this is what the user is saying, but what is actually happening in the system is lesson completion not tracked persistently. So it's because it is not tracked, and that's why these resets happen, right? Correct behavior can be lesson progress saved reliably. So this can be like, if this is done, then the user can stop having the problem, right? So certificates locked after course completion, right? So this is what the user is complaining about, that after they are done learning, they can't download their certificate, right? The certificate is locked. So the system issue could be that completion rules are inconsistent. So it can even be a bug that is happening, right? So this is what is actually happening in the system, and something that can correct it is certificate unlocks automatically after full completion. So you need to be able to set this rule from the system side, right? Another example is users can't see progress, right? The system issue could be cause progress not calculated, right? Because I mean, if it is not calculated, then there's no way they can even see it. So this could be what is actually happening in the system. The correct behavior, is progress clearly displayed as percentage. So you see that when the behavior is correct, right, then the system issue doesn't happen and the user doesn't complain. So I'm not going to really tell you how to frame the problem, because I believe you should know how to frame the problem, but I needed to show you from this perspective so that you know how to properly frame it. So in your first task, you're going to be framing the problem, right? Looking at the scope and everything, you're going to be framing the problem. It is like one of the easiest tasks to do because this is still stage one. So let's move ahead to understanding the system design core concepts, right? So in our next stage, this is going to help us. The level of your understanding here is going to help us tackle the problem better. So let's start. So for the system design concept, for you, I believe everybody here is more like product person or like a business person that is managing a product. So I want to believe that, right? So system design can, like in your day-to-day activity as a product manager, you might not necessarily you know come in contact with probably like designing system every now and then, because system design is something that will likely happen during the design phase. And when I say design phase, I don't mean the UI UX phase. I mean when you're designing the architecture of the system, right? Or when you're updating it. So even though this does not happen regularly, but the day-to-day outcomes, right, that you would get to experience will be a result, or like an indirect or direct result of this how the system was designed, in terms of when you want to scale, how data is being passed, how reliable the system is, and stuff like that. So that's why you need to understand. So even let's say you're a PM, right, you might not really be taxed, all the time on, yeah, you have your engineers and all of that, but it's also very important that you understand how this works. So in case you don't know why you need to do this, this helps you in better decisions, helps you in communicating better with your engineering team, and also helps you with empathy. Yeah. So for you to understand this, actually, I got this. I love the way this image was designed, and I got it from the product notebook. So it basically just takes everything that we're gonna be discussing, and it's gonna be breaking down into sections. So we are just gonna treat it section by section, right? So for you to understand your system design, the first thing that we are going to be looking at, so most of these things are categorized into in such a way that we can call it one thing. So everything in the first one can be considered as scaling systems. The second one, how data travels. The third one, how systems communicate. The fourth one, how data is managed. The fifth one, how reliable the systems are and all of that. The last one, how systems are secured, right? So let's go ahead. Now, for engineers, this could be about how to build these systems, but for you as a product person, this is more like understanding how these choices impact users, timelines, and business outcomes. Okay, so we might not really go over this one by one by one by one, but as time goes on, I'm going to be pinpointing like the most important ones that I would like you to focus on. Right, so let's start from the first one, which is scaling system. So the first challenge that every product, or let me say most products, face at some point is growth, right? So um when you start, you might just be playing around hundreds of users. you know at some point you would get into you know hundreds of thousands of users, depending on the kind of product, sometimes millions and sometimes even billions. So how you design your system can impact how how seamless scalability can work. It might even affect to the point that it might not be scalable if it is poorly designed. So the way a system that is designed for hundreds of users will be different from the one that is designed for millions of users, right? So features that work fine in the early days, might start to slow down if scalability is not properly planned, right? So now, like I said, everything that we are discussing here might not directly affect the problem that we are solving right now. But when we start solving it, you're going to pinpoint the most important ones here that would, directly solve the problem, right? So under scaling systems, we have monoliths and microservices. So monoliths are basically like when you design everything to work like one big system, right? So it means you can't separate the features independently, right? But in microservices, you're able to split the application into smaller, applications, and it will still act as though they are applications, right? So for example, your authentication can be its own application, your notification system can be in its own system. And when you design it like this, you notice that it can even work with other systems, but you're getting there, right? Then we also have distributed systems. So distributed systems are majorly like it majorly spreads the workload across several servers. Now, I believe you already know what servers are, right? In your in communicating with the back end and the client side, I believe you already know what servers are, right? So that's how distributed system work. Now for the cap theory, distributed system introduce a hard reality explained by the cap theorem. So like after now, you can go to the source for from this image. There's an article as well from the author, so it's something that can also help you understand the concept. So even after this explanation, you can still go there, right, and look at it, right? But one of the main things that I want you to focus on is what I call the load balancer. This is going to come pretty handy in what we are trying to solve. So for the load balancer, let me explain what the load balancer is. So let's say you have a server, you have the client, you have the back end. Now, you already know the server is responsible for handling the request to and fro the client and the back and the back end. Now there are situations where there are different servers because of different work that need to be done, right? If you have been in my class, you must have heard me talk about the restaurant scenario. Or you usually use it to explain the how the communication happens. Yeah, so let's assume we are talking about that scenario now where the server is helping with this communication. You want to send a request, you use the server. You want to get a response, you use the server. Now imagine if there are a lot of things you need to do, only one server will not be enough, right? So you might need different servers. Now what the load balancer does is it makes sure that it gives the work to the server that should be given. So if a server has like three loads already, right, just like the name implies, load balancer, if a server has like three loads already and there is one that has none, right, the load balancer knows too well not to give it to the one that has three and leave out the one that has none. So it balances. It's just like sharing the task in a balanced way. So that's what the load balancer does, right? So when it is when the servers are going to and fro, it makes sure that none of the servers is overworked, right? So that's the work of the load balancer, right? So another important thing I'll need you to look at is the content delivery network. So a content delivery network um solves the problem of how do I explain this now? So in content delivery network, right, there's what we call, first of all, there's what we call caching, right? So as your system grow, one of the biggest bottlenecks is repetitive work, right? So if the database has to fetch some data thousands of times per second, or if the application recalculates the same results repeatedly, the system slows down, right? So what caching will help you do is that it helps by storing frequently used data in a fast temporary location so it can be retrieved instantly instead of being recalculated or refreshed, right? So let's use the example in this article. For example, if a customer comes in every day and orders spaghetti, the kitchen doesn't start from scratch each time, right? They keep portions of spaghetti ready to serve instantly. So that's how caching works, right? It helps you keep things that are used often at hand. So that's why if in your system you can also clear your cache, so those ones that are heavily repeated, right, you can basically keep them handy, right, basically. So what the content delivery network does, popularly known as CDN, is that caching works inside your system, right? So but for let's say a server now, like might let's say a server in Lagos might respond quickly to a nearby user, but a customer in London will experience lag simply because of distance, right? So you see that depending on the location, the distance, and also like the speed it takes to get to where it is needed. So basically what content delivery network does is that it solves this by extending caching to the global level. It places copies of static content. It's just like people who sell, let's say you're in UK and you sell a global product, right? And you need distributors. So instead of imagine the time, if a customer orders it from, let's say, Lagos, the time it will take it to deliver from UK to Lagos might take weeks, right? So instead of waiting till the person orders before you deliver, right, you can just keep distributors in different cities, right? So that is what the content delivery network does. So it keeps copies of the the content. This content might be images, videos, scripts on the servers distributed in different places, so that when users need anything, like the client, when they need anything, right, they don't get to wait for a good number of time. They just make use of the content delivery network to get what they need immediately, right? So that helps with speed, and yeah, speed basically, right? So the second thing here is how data travels, right? I know if you're used to API, you should have heard about HTTPS, right? um yeah, if you have like some level of this tech side of the product management, you should have heard things like HTTPS. So I believe the ones that are new might just be IP address, TCP, and probably like DNS, depending on the kind of knowledge that you have. But let's go over them. So for an IP address, right, it is a unique identifier assigned to every device on a network. So remember that everything happens in a network. The client, the server, the back end, everything. There has to be a network, right, for communication to take place, right? So the IP address is a unique identifier assigned to every device on the network. It's what lets data know where it should go and where it came, right? So without IP addresses, your request would have nowhere to land. Now, even your laptop, right? Your laptop has an IP address. So if your laptop now is a client, right? So the thing that when the servers get information from the back end, how does it know where to, just like when you send someone on an errand and the person gets back, how does the person know that, okay, this is where I left and this is where I need to go back to, right? That is through the work of the IP address. So just keep these things in hand. I'm not going to give you any tasks related to this particular one in this stage, just the problem, framing. So the second thing I want you to know is the TCP, which is also known as Transmission Control Protocol. Is a set of rules that governs how data travels across networks, right? So that is basically what TCPs are. And then we also have the DNS, the domain name system, right? Every um every place you visit on the internet has a domain name, right? It's like the phone book of the internet. Computers use IP addresses to communicate, but humans prefer names like facebook.com, right? So the IP addresses now is more technical per se. The domain names are more user friendly because these IP addresses are written in a combination of numbers and those codes. So but the DNS now, the domain name now, has is something that you can easily remember. And you, like, for example, facebook.com, right? We have google.com. So those are the domain names. So the DNS translates human friendly names into machine IP addresses so requests can find the right server. So your system, right, does not understand this DNS. So the thing that makes it to convert to machine readable IP addresses is the DNS, right? So for HTTPS, I think I've talked about this a lot of times, but yeah, it is the hypertext transfer protocol. Now if it has S, right, then it's secure. Some of them does not have S. The on the basic level is just HTTP, but when it has S, then it is the secured version, right? So the HTTPS works, right, but it is insecure. That is when it does not have S. So the HTTP is still okay, just that it does not is not secured. So if you want it to be secured, it has S, right? So HTTPS has a layer of encryption to using the SSL. So this is beyond like what we are doing, but just understand it, right? So when you visit websites or URLs, check out for the, if you notice the one that does not have that S will tell you that this site you're about to visit is not secure. It will give you, and it will always have this lock icon, right, if it has that S1, right? So what the next thing I want us to look at is how systems communicate. Now, if you already, like, the theory part of APIs, then you know that the way systems communicate is through APIs and communication protocol. And we have APIs in terms of architectural design. APIs can be of different types, right? But for this particular problem, we are going to be focusing on the REST, right? So the representational state transfer. This one is easily scalable and it makes use of the HTTP, right? And makes use of the methods like the get, post, put, and the rest. So that is how systems communicate. So if you want two systems to communicate, you make use of your APIs, right? So another thing, now we also have like GraphQL. GraphQL is a newer way of building APIs, right? But REST is still very much new. I actually love REST, right? So GraphQL is like a newer way of building APIs that gives clients more control instead of being stuck with whatever the server decides to send, right? So we have GraphQL, we have REST. Now, what are WebSockets? WebSockets enable real-time two-way communication between client and server, unlike REST and GraphQL. So these WebSockets are mainly used like when you need something in real time. Let's say like you need like a live chat, right? So as it is happening, the other person is getting it immediately. So you can use WebSockets for things like that, right? So for example, rest is like calling a restaurant to place an order, right? And then you wait for the order. While WebSockets are like you keep the phone line open and the restaurant can talk back and forth instantly, even without you dialing, right? So, but don't break your head so much about this. When we start, what we are doing proper, this will make more sense. So, for um how data is managed is more about how data is stored, how data is retrieved, and that is basically through the database. So for database we'll have SQL and no SQL primarily, right? So SQL are mostly structured query language, right? And they enforce strict schemas, like they are very strict in enforcing how they work, while the NoSQL database are non-relational. So SQL is relational, while non NoSQL is not relational, right? So we also have the sharding, yeah, or some people call it sharding. So, but what happens when even a single database is too big to handle? At some point, no amount of indexing can keep queries fast. So there's what we call indexes, right? So an index is like a shortcut that makes database, lookups, faster. Instead of scanning an entire table, the database jumps directly to the relevant row. Okay. So this sharding now enables, you to handle a database when it is becoming too big, right? We also have a concept called replication. So sharding spreads the load, right? But then it doesn't protect against failure. So sharding helps you um spread the load and all of that, but with replication, right, you can basically work against failure. Okay. So another thing that I want us to, like I said, we are not going to be looking at everything here, but another thing I want us to pay attention to here is monitoring and observability, oh my god, observe observability. Yeah, observability. So it's like you observing. So when your system is running, right, you need to constantly observe, monitor it, right, in case of any issue, right? So imagine a running restaurant blindfolded without feedback from your staff and customers. You wouldn't know the kitchen. You wouldn't know the kitchen is on fire until people stopped showing up, right? So imagine your system is on, right, and there are customers, real customers or real users in the application complaining because you're not monitoring it. You don't even know when the server breaks down. You don't even know when the system packs up. So but with monitoring tools and systems, you can get alerts on when these things happen, right? So that's that with when you monitor it, right? So because you're able to monitor it, you can also recover issues faster, right, when issues happen, right? So the last thing we are going to be looking at is securing systems. So if you're able to know the theoretical part of these things, then when we start or let's say when we go deeper, because we have already started. So when we look at securing systems, so securing systems, inside securing system we have things like authentication versus authorization, encryption, rate limiting, and throttling, right? But securing system is just about making sure that the system is well secured. The person who is not supposed to have access should not have access, and when the person who has access wants to come in, they are actually authenticated and given access. So that's what the securing systems mean. Firewalls are mainly connected to the internet, right? So some of it might be good, Legitimate users making requests. So some of it might be, some of it, is good legitimate users making requests. Some of it might be malicious, right? So what the firewalls does for you is that it acts as a gatekeeper, filtering traffic based on defined rules. So only safe requests get through. So all these things here, firewalls, authentication, authorization, encryption, they are mostly about, securing your system. So encryption means, hiding data, in such a way that only people who have the right authority can read it, right? So there's a way data can be coded that if you don't have access, even if you see that data, but because it is written in a way that you will not understand, so even if you break into the system, because it is coded, right, you won't be able to understand what that data represents. That's encryption, right? And then for rate limiting, so for users that overload a system, sometimes it can be intentionally, right? Sometimes it might not be intentional. So rate limiting caps the number of requests a user or system can make within a given time. And that's why sometimes when you want to log into a system, it will tell you that, oh, you can only try your password 5 times. It is threatening late limiting, that I mean rate limiting, that is in charge of doing that. So this is the foundations of what we are going to be doing. So but I'm going to give you a task, and that task is just going to be for you to frame the problem, right? So one thing that is going to be important for us in this particular challenge is, one, your presentation, because this is the technical side of things. Is not UI, is not wireframe, is not what is it called, is not sketches. So it's not something that the normal user can understand. So your ability to write well, your ability to present your thoughts well, your ability to arrange your submission well and make it visually presentable matters a lot, right? So you also, like when you're generating your portfolio, you're going to be writing a case study of your thought process on how you solve the problem. So ensure that you take care of that part, right? Because yeah, like I said, this is not a UI UX, this is not the design side of things. This is like the part of the system that the users do not understand, right? Typical users do not understand. So I think that will be all for this particular one. So do your stage 1 task and expect your stage 2 pretty soon.